Teaching techniques. When dealing with interior angles, problem-solving questions can help check students' understanding and get them thinking outside the box. Here, we want to find angle X. We can do this using interior angles. So we have a square here, and the interior angles of a square are 90 degrees. Each of these angles is 90 degrees, a right angle. This by itself should earn a mark in a question. Now we need to find this interior angle of the hexagon. There are 1, 2, 3, 4, 5, 6 sides. So using the formula n-2 times 180 divided by n, where n is the number of sides the shape has, this is 6 minus 2 times 180 divided by 6. This finds the size of one interior angle, which is 120 degrees. The interior angle of a hexagon is 120 degrees. To find x, we now need to use a different angle rule. We need to recognise that these three are angles around a point, meaning they need to add up to 360 degrees. So to find x, we have 360 minus 120 minus 90. This leaves us with x equals 150 degrees. We have found x by using interior angles of a square and a hexagon, then recognising that these are angles around a point. Now we can have a look at some different shapes. We see here that we have a quadrilateral, ABDE, and an isosceles triangle, indicated by these two congruent lines. What we need to find here are angle x and angle y. Since this is an isosceles triangle, this means that angles CBD and BCD must be equal. 180 minus the 120 of the top angle and divide this answer by 2. So we get angle x and its equal angle BCD to be 30 degrees each, which we can label on our diagram. We know that the interior angles of a triangle must add up to 180, so we can check this. 30 plus 30 is 60. 60 plus 120 equals 180 degrees. Before we find y, we need to apply another angle rule, since we do not have the three angles needed to find the fourth in the quadrilateral. However, we do have angle x as 30 degrees, and it's on a straight line, with the third angle of the quadrilateral. This means the two angles must add up to 180. If angle x is 30, this angle ABD must equal 150 degrees. We now have an irregular quadrilateral with 3 of the 4 interior angles known, meaning we can find the fourth. We know the interior angles of a quadrilateral must add up to 360 degrees. So we subtract 108, 54 and 150 degrees from 360. We are left with angle y, which is 48 degrees. Angle x is 30 degrees, angle y is 48 degrees. We have used interior angles of a triangle, angles on a straight line, and interior angles of a quadrilateral to find them. Now we can try an example that uses algebra. We see that shape ABCD is a quadrilateral. We can also see it is irregular, as the 4 angles are all different. The question asks us to find the size of the largest angle. In order to identify the largest angle, we first have to know what all the angles are. Although we know these sizes of 47 and 100, we do not know the numerical value of these two angles, ADC and BCD. So to find these angles, we need to find what x equals. We can use total interior angles of a quadrilateral to find our answer. We know all the angles together must add up to 360, and if we add up the angles here, we have 147, from 147, plus 3x from x and 2x. In order to find x, we now have to solve this equation. 147 plus 3x equals 360. We are not just looking at angles here, we are solving algebraic equations as well. Subtracting 147 from both sides, we get 3x equals 213. If we want just one x, we divide 213 by 3. This gives us x equals 71 degrees. Now that we know x is 71 degrees, we can substitute this back into our diagram. 71 degrees is x, which means 2x equals 142 degrees. Now that we have our missing angles, we can answer the original question. Work out the size of the largest angle. We can clearly see that 142 degrees, 2x, is the largest angle. Deep thinking. Brendan says that angle x is 36 degrees because 360 divided by 10 gives 36. Explain why he is incorrect. We have here a regular 10-sided polygon, and we want to find the size of an interior angle. We know that to find the interior angle, we need to use the formula n minus 2 times 180 divided by n, where n is the number of sides of the shape. This is 10 minus 2, which is 8, 8 times 180, all divided by 10. 8 times 180 is 1,440, and dividing this by 10 gets 144. We now know that the interior angle of this regular 10-sided polygon is 144 degrees. Another way to find this would be by finding the exterior angle first. The exterior angle is 360 divided by 10, the number of sides, which equals 36 degrees. If the exterior angle is 36 degrees, and the interior and exterior angles are on a straight line, then the interior angle must be 180 degrees minus the exterior angle. 180 minus 36 is 144 degrees. We can find our answer using the formula or by using the exterior angle. Either method shows us that the answer is clearly not 36 degrees, as Brendan said. To challenge students, we want to know what Brendan has done wrong. How has he gotten the wrong answer? More able students should recognise that the formula he has used is for the exterior angle, which we have used here. 360 divided by the number of sides is how we find an exterior angle. Brendan has mixed up the formulae, which will be a common mistake on this type of question. He has worked out the exterior angle, but then not used that to find the interior angle. Exposing students to this kind of mistake is firstly a good way of getting them to recognise the correct method, and secondly, they may notice they have made a similar mistake, and they should now register not to do the same thing again.